All right, today what I want to talk about is Remix and the different loading patterns that are available to you. This tutorial basically assumes that you've got some kind of experience with Remix, or at least a decent experience with web development and React development in general. But essentially what I want to do is walk through the different ways that you can go about loading data in Remix. There is certainly like the prescribed way, and there's also a couple other ways that you can load your data with Remix. Remix really kind of is assumed that you are going to be able to have a fast API and that you can load your data almost instantaneously. One of the biggest things that they kind of push is that you no longer have to see a loading screen anymore. It's just that the data appears immediately whenever you go to a page. There's no more waterfall requests or anything like that. While that sounds great in theory, as I've been working with Remix for the last 6+ months, I've realized that that's not always the case. You can't always expect that you're going to have an instantaneous API. What I consider to be instantaneous, somewhere around 200 to 400 milliseconds, something that feels pretty snappy. When you click on it, you expect the page to upload or update relatively quickly. So what I basically want to walk through is the prescribed way of loading data using their loaders, and then also there are two other methodologies that you can use to in case you do kind of have a slower API, that you can increase the user experience overall. So essentially what we have right here is I just built a real simple riddle application. All it does is we've got three different tabs up here. You click on them and then you get a different riddle thanks to ChatGPT. So nothing too crazy going on here. What I'll do is I'll walk you through the code, what we currently have set up, just so you have a lay of the land, and then I will walk you through the different loaders that we have. I've built out two of them so far, two different ways that we can fetch the data. We will be walking through a third way at the end of this. So as you can see, we're just switching through, nothing too crazy here. So the first thing I want to show you is we'll go into the Remix application. You'll see that there are a lot of files here. Essentially what I just did was I cloned one of their templates and then just made some modifications. So you definitely don't need all of the files here. We're not using Prisma or anything along those lines, Cypress or anything like that. I'll just walk you through the stuff that we will be using. So the first one that we have here is just I built this tabs component right here. Pretty straightforward. It just renders a list of tabs. We just have some tailwind for some styling here, and then we've got active class and inactive class. And the cool thing is if you use the nav link that comes with Remix, it is aware of the actual path that you're on right now. So then it gives you this handy little is active callback that you can add to your class name, so you can toggle classes accordingly. So that's how we're rendering the tabs right there. The root, pretty straightforward. All we're really doing is we're just rendering an outlet here. And if we go back to the browser, you'll see that we've got the path is riddle, and then it is a variable name for the actual tab that we want to be on. So if we go to close this on up and we go to routes, you will see that I've got a riddle, and this is kind of like our top level route right here. And essentially all we're doing is we're just rendering an outlet, we're rendering the tabs here. And I've got, like I said earlier, I've got two different ways right now that we are loading data. One is just /riddle, the other one is riddle.defer. So don't worry too much about this, just a little logic that I had to do in order to get the route, this tab component to work in both scenarios with different route paths. So the first thing that I'm going to be going over here is this riddle.name. This is the one that we're currently on right now. And let me just walk you through the code real quick. So we're just, we're hard coding some stuff here. We've got a few different riddles and just hard coding the values right now. And we've got a loader that then makes a call to get riddle, and that then gets passed on down to the actual component itself. So let me clean some of this stuff up. So this is pretty straightforward. Most applications that you have with Remix, you're essentially going to have a loader. It'll process some parameters here, and then you'll make a call. This is basically simulating a call to a database or an external API. So you can see that we're awaiting it. I've got it wrapped in a promise with a set timeout, and the set timeout is just set to 0. So basically it's just going to immediately resolve. The reason why I'm doing a set timeout is I want to be able to simulate some kind of a slow API or network latency, something along those lines, to have something to make it feel a little bit more realistic for like a production application. So all we're doing is we're just awaiting for the riddle to come back, and then we go ahead, return the JSON, and then in our component we are deconstructing the loader data. We're grabbing the riddle, and then we're just rendering it as HTML right in the client. So nothing too crazy there. You can see that we're jumping around. Everything looks good. It's nice and snappy. You can see that there's no real issues there. And if we hop on into our dev tools and we jump around, you can see as we go from one to the other, it's updating pretty quickly. 500-ish milliseconds. I'm sure that if we had a production build right now, it would be significantly even faster than that. So what I want to simulate is some network latency. So what I'm going to do is I'm going to jack this up to, let's do 1.5 seconds. Okay, so we save that. We go back over here, all right, and now you click on it, and nothing happens. You can see that it does make a network request, but it's very slow, and it's not a great user experience, because typically what a user would expect, they do expect some kind of a loading, so that's understandable, but they don't expect is the UI not to update. And as you can see, I click on this right now, nothing happens, the tab doesn't even update. It's really just not a great user experience, and this is simulating what would be a 1.5 seconds response time, which depending on your application, sometimes you just can't do anything about it. Maybe you just have some highly complex data on the back end, or just a slow API, and there's nothing you can do about it. So 1.5 seconds, that is relatively high, but even if you set that down to a second, like, it's still not a great user experience. Like I said, something real time, you really want to shoot for that 200 milliseconds. Sometimes I feel like you can get away with potentially 400 milliseconds, but it's ultimately up to you as a developer or the product person to kind of determine, like, okay, what's going to be a reasonable expectation here in terms of user experience and the load time. So you can see that that's not great. There are a couple things that we can do. You can actually detect whether or not that this is loading, and this is what we'll do, and we'll display some kind of a spinner here. So in order to do this, we want to do const nav equals use navigation, or sorry. And then we're going to do nav state is equal to loading. And then we will basically just say is loading. I know that they're probably going to try and fill up the whole entire screen, so we'll just go loading diff. Okay, so pretty straightforward here, and we'll close that on now. So now if we go back to our app, all right, clear that out. So at least now you get a loading screen, but still, it's not a great user experience. It is slightly better than what we had previously, but the tabs, they're still not updating, which is pretty annoying. You're still getting the old page while you're waiting for it to load. You just have this extra loading here. Once again, that's not ideal. We should at least be blowing away this page and just have loading only. So, and we can do that. We can update things to do that. So basically say, like, if it's loading, then just don't display the comments at all. But what we really want to do is we want to update the tabs. So let me go on over. I want to talk about, I've got a deferred version of this. So basically we're waiting for all this value to load on the server. A better way, in my opinion, when you have this kind of scenario is I've got essentially the same exact application as before. We've got the different riddles and everything like that. We've got this get riddle. Let's jack this up to 1.5 seconds as well too. But there's a couple small differences here. Is we no longer have an async await in the loader. Right now we're just fetching it, and this is an actual promise, and then we're using defer instead of JSON. So what this is essentially doing is it's starting the request more or less on the server, and essentially once the client will then render immediately, but it's going to be a promise in the client. So the client has to wait for that promise to resolve in order for the data to be displayed. So let me just clean that up real quick. So you can see we've got a couple extra things here. We are adding a suspense. This comes with React. Actually, it is not specific to. It's not specific to Remix. This is a React component here. So suspense, basically what it's doing is it's saying, okay, if there is a promise somewhere below down this component tree, then we're just going to render this fallback until that promise resolves. And then we just have a key property here. I won't go into the details of this, but basically if you're on the same exact route and the name is changing, like the path name, but a variable in the path is changing, but you're on the same route, you need to give it a key so it knows that it needs to update the UI. So inside of that, we've got await. This comes with Remix, and we're saying resolve riddle. So riddle is a promise, as you can see right there. And we're waiting for a riddle to resolve before we continue to render the rest of this. So this will not render at all until riddle has been resolved. And then essentially what await does is then it's kind of a high order component here, is it gives you a callback where you then actually get the resolved value, and then you can go ahead and render it. So let's see, let's take a look and see how this actually works. So if I go back over here, I do riddle / defer / react. Okay. So now the big difference here is when I click JavaScript, you can see that the tab did update immediately. There's a very small delay, but I think if you just had a production build, it would be a little bit faster. But you can see that it does update immediately, and then it gives you that loading screen, and then everything is good. So it is a much better user experience because you don't actually have to wait for all of the data to load before that tab updates. The tab is updated almost instantaneously. So it's just a much better user experience in that way. So so that's two different ways that we've looked at loaders and different ways that you can load data into your application. What we're going to talk about now is a third way. So the nice thing about going the deferred route is that you've got one centralized location for a specific page or a specific route to fetch all of the data that you need for that page. So it's kind of a good source of truth to know where everything is. But sometimes when you've got like a highly complex web application, let's say that you have a bunch of different components on page and they've got all of their own data that they need to manage, you might want to go a separate route, no pun intended. You might want to go a separate direction though to fetch your data where the components are actually responsible for fetching the data, and you just kind of want the page itself just to be a general layout for the actual applications, but the component, they need to be fetching their own data. So we will go ahead and mock out what that might actually look like. Let's do a third one here, and we'll do riddle.resource .name.tsx. Okay, and what we're going to be using is a resource route, which is something that is a part of Remix. So I'm going to copy and paste the same exact thing because it's going to be pretty similar. Okay, but I'm going to be removing some stuff here. Is on this, we'll just get name. We don't need anything else. We can remove the comments. That's not actually part of the application. Then we don't need this. Okay, and we will get rid of this as well too. We'll just say riddle, and we'll throw in the name. Okay. We will need to update this. So we'll just say base path is equal to, I don't like doing nested ternary operators, so we will say the default is this. So this is just to update the tab so that we've got the proper navigation structure here. Base path is equal to this. Okay, and then if it includes resource, we'll do riddle resource. Quick fix. Yes, I do mean base path. Okay, so that'll just handle the tabs, make sure that that's all good. Let me remove this. Okay, cool. All right, so if we go to, so instead of defer, we'll do resource, and it should be rendering basically the same. Okay, cool. So you can see we're just switching from one tab to the next, but now we want to actually fetch the data using a resource route. So essentially what a resource route is a route within Remix that doesn't actually render a component. So you can kind of think of it as like an API route. All it really does is return you JSON for the most part. So what we're going to do is we will then create a riddle.name.tsx. Actually, we already have that. Resource. Name.tsx. Okay, maybe not the best name, but we'll just roll with it. So export const loader. And we want to get the params from loader args const name params. Okay. And essentially what we're going to do then is we're going to move this on out into a model. So we're going to create a model. We'll just call it riddle.server.ts. Okay, and we're going to export it. So this is very similar. If you're not familiar with MVC, model view controller is essentially you want to have functions that wrap around your actual data, the way that you access your data, so that it can be used in multiple routes, as opposed to just hard coding that those functions directly into your routes or into your loaders, whatever it might be. It's good to have separate models so then they can be shared across your entire application, and that's what I'll be doing right here. So what I want to do is get riddle. Okay, and we'll just say name, and we'll do return JSON. Okay, and cons riddle equals await. Let's add in async. So this is exactly the same thing that we had in the previous example, in the very first example here. So, so we close this one out, and we go over here. Okay, we can delete this because we don't need any of that. What we want to then do is we don't even need a loader now anymore. Actually, I'm sorry, we do. We're going to keep the name here. So nothing's changed. Let me just show you that real quick. Everything's still good. Okay, that's rendering, but now we actually need to fetch the loader. And this is one thing to note is that we are switching to client-side rendering. So where Remix likes to do everything server-side, wherever possible, it's obviously the most ideal scenario. Sometimes you do have to depend on client-side rendering. So what we're going to do is add a use effect, and use effects will only ever run in the client. Okay. And leave that empty. And we're going to use a fetcher. So fetchers are basically ways for you to communicate with the back end. You can either submit data to an action, or you can also fetch data as well too, using fetcher.load. Fetcher equals use fetcher. And this is, once again, this is part of Remix here. So we're going to do fetcher.load. And I believe that this resource route, let's double check it. But if we go here, we'll open up a new tab. So it should be resource route, and then name will be React. It should just return a regular JSON response, and as you can see, that's exactly what it does. So this is what we want to get. Okay, and then you just give it an API endpoint. This is essentially the same exact thing as using like a just a regular fetch request here. So there's a couple things that we need though, is the name. We want to run this whenever the name changes, and we need to pass that value on in. And then the cool thing about fetcher is that you can see we got the data. So console.log. So now we should see it showing up in our application. It's not going to update the UI just yet. We'll get to that in a second. But if I go over here and you switch, let's see what's going on here. Okay, cool. I just need to do a refresh here. So you can see that as we are changing, we are logging the different values. So that's excellent. So now we can actually render this inside the HTML on the actual page. So if I go back over here, I just grab the code that we had before, which is just this paragraph tag. We can do this. Okay, and then the riddle is actually going to be fetcher dot. Okay, but we actually, yeah, we can do it like that. There you go. So you can see, just like the deferred version, is that the tabs do update immediately. We just don't have a loading screen right now. So this is another thing that we can do. So you say fetcher dot state is equal to loading. Then we're going to do this. Otherwise, we're going to then render the actual data. This is very similar to what we just had before in the deferred example. Cool, so you get a loading. Once again, you can see the tabs do update almost immediately. So I click React. There you go, you get a loading. So much better user experience. Just to compare it one last time, if we go back on over here and we just go to riddle JavaScript. You click on it. The tabs do not update immediately, and that's basically the issue that we're solving here. So as you can see, Remix, we've got 3 different ways that we can go ahead and fetch our data. The first one is just using a traditional loader. Benefits of that is that you've got server-side rendering across the board. There's really no loading screen. You can have a loading screen if you want, but you don't necessarily need it. One of the downsides is the UI does not update instantaneously. Reason being is that Remix doesn't actually navigate to the new page until all of the loaders for that specific page have completed. So it kind of just gives you this stale UI. It doesn't really blow anything away. It doesn't update the UI as responsively as you would expect. The next way that we went ahead and we fetched our data was to use Deferred. This is using HTTP streaming. So basically you kind of start the request on the server, you then push it on down to the client. Then when that actual data has resolved, then it will update the UI. One of the downsides with this is you have more of a loading state, but the good thing is that your whole entire page is not blocked until your slowest request is finished. You can just start rendering that page immediately, and then as the data continues to come in, then you can start rendering components. The nice thing about that we didn't really touch on is if, let's say you've got maybe 10 different components on the page, they've all got 10 different separate APIs that need to be fetched in order to render everything, and you can render those 10 different components. The nice thing is with Defer is that you can just load the entire page with the 10 components, and as the data comes in for each and every component starts to appear. It's really ultimately up to you or your product designer as to what is the best user experience. Some people don't like the jank that you get going from a loading state for a specific component to the actual data in place. So it's really kind of an art more than it is a direct science on how to do this stuff. So the very last thing though is using a resource route. So this is very similar to how we kind of build applications for maybe the last 10 years or so, is that everything is kind of client-side rendered. The components are responsible for fetching its own data. There are some, this is probably the most flexible route, but it also requires a little bit more work. You don't have a single source of truth like you do with a deferred loader or a regular synchronous loader. But at the end of the day, the component itself is kind of isolated and has its ability to fetch its own UI or its own data for its own UI. So those are the 3 different ways that I've kind of been using Remix to load different data depending on my use cases. And I would say one of the most important things is the use case really depends on also how you want to mutate your data and update the UI in that way. So what I'm going to be doing in the very next video is I'm going to be talking about the different ways that you can update your data, perform actions, and submit some kind of mutations that then update the actual UI. So the way that you fetch your data can be highly dependent on the way that you mutate your data, and I'll talk about that in the next video. So if you enjoyed this video, please give me a thumbs up. A subscription would also be very helpful trying to grow this channel and make sure that I can educate people on React, Remix, Next.js, whatever else it might be.